Hello, everybody. So we're up to week 6 now, which means we're very quickly coming on the end of the 8-week course. Along with that, probably slow down a little on the lectures and have less lecture time and more time to do stuff and catch up on all the work that we might be falling behind on and things like that.
Oh shit, I forgot.
What was that?
Oh, nothing. I forgot to mute Mike. Sorry about that.
That's all right. It sounded very important.
No, it was just one assignment I forgot to do. So
Okay. For
Yeah.
my class or another one?
oh no, a different class.
Okay. I always hate when that happens. I remember I once forgot a test day. I got to class and walked in, sat down, started pulling out things out of my backpack like normal, and looked around and suddenly realized all of my classmates looked really nervous and were desperately digging through their notes as quickly as they could. I was like, oh no, I completely forgot we had a test. This is not going to go well. But I guess it could have gone much worse than it did, but it did. That sort of thing does initiate a bit of panic in us. Okay, so we got a few things to go over today. The main topic for this week's getting into cybersecurity. No problem, Joseph. We all do that sometimes. Forget our mics are muted or something. It happens. But our main topic for this week is cybersecurity. And at this level, that's a bunch of definitions. Where's my list? 1, 2, 3, 4, 5 pages of definitions. So we'll probably start writing those out because that's a lot of just words to list out the definition of and talk about a little. So probably start on those today and finish up that list on Thursday. There were a couple other things. Yeah, that way we're not sitting down just jotting down definitions in the notebook for an hour and a half straight. Kind of break that up because there were a couple things from last week that we ran out of time for. One of those was the OSI model in particular. We talked about the transmission control protocol, how we actually send our data across the network, break it down in little packets and add in extra information and what that extra information is about, because that's something you'll be tested on in multiple classes in the future. So previewing it will be helpful for when you get to those classes. I have some other notes about the labs, just little things to go over. I guess a good starting point is something with from last week's discussion board. There was different, a lot of different graphs and things talked about. There's something else I want to talk about with graphs and visual representation of data that relates back to that business perspective, right? We want to learn things from the business perspective and what's good for the business. I have it on the plan for next week, but there's still a little bit more to talk about. But one thing I noticed was in describing the difference between bar graphs and bar charts and histograms, there's a less formal definition that makes it a lot easier to make sense of sometimes. Let me get these names on the list. That way I don't forget to mark them down. But with bar and column charts, I think everybody remembers back from math class, we have our X and Y axis, 2 numbers. Usually our X axis is considered the independent axis. And so the vertical value depends on where we're looking at horizontally. We always use X and Y in math class because those are nice generic terms. They don't stand for anything. But we're Americans, so time and money often make more sense in our minds because that works into our daily lives a lot more. And time is about as independent as things get. All we can do is look at what time it is, and there'll be some sales figure or something that corresponds to it for a list. generic version than we usually see in math class. And then we plot all our points. So maybe we'll have so many numbers going up the side and our different values down on that independent axis. And then the discussion board, lots of people put out the definition that spells out very explicitly and formally the difference between bar charts and histograms. But a nice little less formal version that I think is helpful for remembering it is a bar or column chart. I guess there's a technicality here. Technically, bars go vertically. So the ones that would get plotted this way would be a bar. And bars go horizontally and columns go vertically. So technically the charts that look like this are going to be column charts, but that's another one of those technicalities that we probably don't want to work in our sentences, because just from the way people talk, they're both generically referred to as bar charts. And histograms are actually closer to a column chart the way we usually think about them. But the point I wanted to express, the less formal version of it would have to do with where we mark our data. So we might have several different data points, bars of different heights. And on a bar chart, they're usually centered around those marks that we're looking at on the x-axis or our horizontal axis. So the bar would center there, would kind of center on the mark, and there's no separation or value between them. So things that are distinctly different. Like ages. Once we pass the age of 3, we stop including halves and quarters, and we just give the whole numbers. So people are age like 3, 4, 5, with no overlap in between them. Or colors, if we had a short list, the red or green or blue, and it's strictly into one column or another with no overlap between where those columns go.
Sorry, I'm late.
All right. And a histogram would kind of, let me erase these bars real quick. No, we don't have to redo the whole chart. Technically columns, we're just going to say bars when we speak. And a histogram, instead of being centered on those values, the histogram would include all the values in between. So a histogram really goes in between the things. So weight loss is a common thing that's easy to visualize. Right? If we when we go on a diet, get a bunch of exercise and all that, tell our friends how much weight we lost, but we usually round that off to a number. Most people here are probably well aware that air is very heavy, right? So if you're standing on a scale and don't like that number, you can breathe out, and because your lungs hold 3 or 4 pounds worth of air. If you lose, say, 5 pounds, that's going to change next time you drink a glass of water, because water and air are very heavy, and it varies, but we pick a number, and usually we don't pick the exact number, right? Numbers, they're real numbers, so there's all those values between. We might say we lost 10 pounds, but we actually lost 10.387294 pounds, right? All those extra little fractional parts that we're not going to say, they go in between it. So they're more for ranges, but that's the short generic version. Less formal on when to use each one. When we plot it on our axis, is it going to be centered on that value so that there's no overlap crossing to the next one? Or is it between those 2 marks on the axis? Sometimes the less formal definitions are a lot more useful for when we want to apply things. It's like putting it in normal everyday English, the language we actually speak, instead of that technically correct version. Yeah, so they look similar, but they measure very different things. And sometimes the technical definitions can be very close to on those two sometimes. So I wanted to make sure and express that. Another thing related to histograms is histograms aren't very intuitive to make in Excel. So let's go over the steps on that, because it's a very popular way to visually represent data, but it's not very intuitive to make in Excel. So usually, well, I'll kind of set up some stuff. So maybe a weight loss example that's on my mind because we just did that a second ago. So like 0 to 5 pounds, 5 to 10 pounds, 10 to 15, 15 to 20 pounds, something like that. It's probably good enough for our example here. Well, I guess some people continue diets for a long time, right? 20 to 25. And you can almost see that thing I was talking about in the labels, right? 5 shows up in both of these labels. And we never expect anybody to lose exactly 5 pounds, right? 5.000000 pounds. We know it's going to be around 5, but we're rounding it, cutting off all the fractional part. So there's that overlap, and we really want the range, the area between the tick marks on our axis, not the actual ones. And then, I don't know, maybe a certain number of people lost that much weight out of a big group. I'll just make up some numbers here. 3, 5, 5, 2, 2. Whoops, not 23. 2. So just a couple numbers, and on most of our charts, all we gotta do is select it and go to insert, and then we can choose it right off the list, right? Recommended charts, they'll have the bars, a few different ones here. There's a button for histogram, but if you click that button, you'll kind of get it, but you get less control over it than you would if you click the bar chart button. So a better way to make histograms, kind of the standard, and if you're not on the if you don't have a fairly new version of Excel, that histogram button won't even be there. I don't think Google Docs or Mac Numbers has it, so you still have to do this way on those as well. They don't have the histogram button yet. So to make a histogram, well, we start with a bar chart, but then change the layout on it. So you go like click on one of the bars, or I usually click 3 times, and really you can click anywhere 3 times just to get the menu at the side, and then select any of the bars. And to turn a bar chart into a column chart into a histogram, we just need this option right here, really, the overlap between them, and the width, change the width between them, because bar charts have that clear separation, so we don't need that separation. You can take that down, make it overlap a little if you want to. Really getting rid of the width will turn a bar chart into a histogram, and that will work on all the spreadsheet things. And we actually end up with more options for controlling and customizing it and making it look really nice or really generic, depending on which one we're going for, if we use a bar chart and modify it instead of the histogram button. But the histogram button in Excel is fairly new, and some of our other spreadsheets don't have the histogram button yet. Probably won't be long till they get it, but we still get more control over the other one. So one more time on that, because you probably won't see it. You won't see the instructions again before the next time you need a histogram. So you create a bar chart and then just click 3 times, and you'll get the little menu at the side. And when you select one of the bars, you can, from the series option, the one that looks like a graph, you can change the gap width and the overlap to make the bars look like a histogram. And then your labels are all in the right spot and everything should follow suit from that. Oh, no, don't save that. Don't need to keep that one around. I just threw it on the list because that's one that a lot of people, it's a lesser known thing. And the button for doing that is fairly new and not in every spreadsheet option. So just in case you need that at some point, because it's a very, very common chart to not, to take extra steps to make out of a spreadsheet. Oh, one little quick note about the lab from last week, the networking lab. I should probably make a note on there and those instructions about it, because questions seem to come in on one of the things that I asked you to do was after you grabbed the IP addresses for Ivy Learn or my Ivy, wherever I asked you to grab the IP addresses for, I said copy and paste one of those into your actual browser. Put that address in directly. I think it was Ivy Learn. I'll just do that directly. So we have these nice little words, meaningful for a human to use, easy for us to remember, but it doesn't mean anything for a computer. So a computer has to translate that, contact some DNS server, and there's quite a few. On my personal site, the address that I don't really give out to anybody or anything, just a random thing I keep around in case I need a random server to work with quickly. There are 4 DNS servers connecting to that. So something big like Ivy Learn, there are probably lots and lots and lots of DNS servers. So it's going to connect to one, spit out a few addresses. And the machine actually uses, this is what the machine actually needs to connect. And I ask you to copy that and paste it in your address bar directly.
Got a question.
Yes.
When I did the lookup in the terminal, I pasted one of the IP addresses into the search bar,
Yes.
and when I searched it, it came up as
Oh, that's what I was looking at right now, Dylan.
yeah, it said that it was, yeah, it said that,
Yes.
and I didn't know what to do.
That's what I was wanting you to see, because this has to do with the DNS stuff. So sometimes we can do that directly. Let me put one up real quick. I might have to start a server real quick. This will just take a couple seconds because sometimes we can do that directly. Oh, yep, it's not running. Where's my start button? Start. Did I click it? I don't think I clicked the button. Start. The Zoom thumbnails are in the way and keeps making the button go away when I try to move them. There we go. This will just take a few seconds to spin up and is it started? Oh, there we go. So if I grab the little IP address here, oops, hit the copy button and then open a browser and paste that in, it jumps over to that server with no trouble. It's not the Apache server would need started. I need to go in here and start it up and stuff, but we didn't get that weird thing that looks like an actual error message that says don't go to this site, right? So we can put that in, but the difference is that this server specifically has a name tied to it. That's what our domain name server is. So humans are expected to use the words. So whenever we enter an IP address that has a human readable thing, the computer kind of has it hard coded in to be like, this is strange access. Humans should be using words, not numbers here. Does that make sense to Dylan? Was that what you were asking about?
Yeah.
Yeah. So while we can do that, if there's not a name supplied to it, when there is a name supplied to it, programmers went ahead and hard coded in a panic button. It's like humans should not be accessing through the number if there's a name available. There's ways to get around that. There's no way to prove who it is. So the domain, the DNS has the confirmation for that. So there's no way to confirm that one. But there's ways to get around it. Some people, it always happens without fail. At least one person tended to bypass that and access it directly. But I was expecting you all to see that error message to make that point. When there's a name attached to it, usually it causes a bit of panic if a human tries to go in that way. But on that other one I started up, which the list for stuff to do today is kind of short, so I guess I could go ahead and start that up. Oh, is that not it? I haven't been on this one in a minute, so I have to look for where it's at. Okay. Opt lamp. .sh. Maybe. I can remember the password. Okay. So now if I go type that same address in, we should see something. Yeah, so it's not connected. That one does not have a domain name connected to it. So the IP address will work directly. But if a human is expected to go in there, then I think I just closed this. If a human is expected to use the name, there's sort of a panic button hard coded in, which kind of relates to the security issues, because that would kind of trigger a warning that, like, well, if IP addresses are being directly typed in, that sounds like something a machine's going to do, not a human. So I guess it's kind of a security thing that people shouldn't be doing that. And it raises questions whenever it happens. So I wanted y'all to see that message. And some people just went ahead and went around it. Some of y'all are used to things like that, and I guess thought that you wanted that. I wanted you to gain access. I just wanted you to see that no access message. But good job on the ones who went around it. That's kind of some impressive roundabout hacking stuff. It's not the easiest thing to get around. You have to bypass a couple of security protocols to do so. Okay, the next thing I wanted to talk about was something we ran out of we ran out of time for last week. And we talked about transmission control protocol. Or TCP, since in our modern world, you've surely heard those letters before. Transmission control protocol is how we break our data down to send it across the network. And then we use IP protocol, internet protocol, to find the best route through the network. might be a good question to think about. I'll answer this later, like in a couple days or so. But part of last week's networking lab was that trace route, right? To show the route that it was taken. But last week when we were talking in lecture, I said every single data packet takes an independent route through the network. Which one are we looking at when we run a trace route? Just think about that for a couple days. I'll talk about the answer. I'll give the answer later. But if every packet's running its own independent route through the network, we didn't see lots and lots of routes, right? When we run a trace route, we only get one. So maybe think about that question. What are we looking at when we see that trace route through the IP protocol? So it's a way of breaking down our data. So I'm just going to draw this so it looks like kind of a file. We have some sort of file, maybe an image file, a document, something we need to send across the network. So transmission control protocol gives us a way to break that down. Usually I do this on a whiteboard, so I have color coding things here. Maybe it'll work here. Do I have color chalk? I might need to get out some color chalk. Couple colors there. So we have this file, we break it up in pieces, and then each piece finds its own independent way through the network. So this little chunk of bits will come over here and get assembled, looks something like this. This piece coming through separately comes over this side, looks something like this, much bigger piece. What else I got? That orange one comes over here to the middle. Something like that. Oh, I guess I did run out of colors. I'll make this one piece. The red one here coming across the network and gets assembled there. Have any other colors? Nope. Never use a color. White, that'll work. And a white one come over. White piece comes over here, fills in that gap. I like to draw the picture like that. We have that nice solid file. It goes across the network and gets reassembled, hopefully correctly. But I tried to intentionally leave some gaps there because y'all have probably encountered that before. Sometimes not quite everything makes it across the network perfectly, right? Little glitches will work in. We're used to it. Probably already happened on the Zoom call at least once today. Got a whole bunch of people on the Zoom call at once. So somebody's probably seen a little glitch in either audio or video in the half hour we've been on here so far, where it didn't quite get assembled correctly on the other side. And in order to do that, to break each piece down, we need some extra information. So not just the data itself, but instructions on how to put it back together, where it goes and things like that. And that's what's known as the OSI model. So the OSI model has 7 layers in it, that we need them to transmit this data and reassemble it on the other side. Which side should I start at? Bottom or the top? I'll start at the bottom. So down at the bottom is the physical layer. which is the actual data itself. So all these chunks that I drew in the picture, that's the actual data that we want to transmit. And so we break it up into little chunks, usually a preset size. Might choose something like 1024 bits. And however big our file is, break it up into little chunks that are each 1024 bits long, and then that gets loaded into the physical layer. Right above that is what's called the data link layer. And really the names of the layers are going to be tested over in multiple classes moving through your program. So wanted to make sure and introduce them here. That is, throw a little over here. So the data link, I should stand on this side so y'all can see the words I'm writing. The data link is the format it takes in transit. I'll write it like that. Format in transit. Where'd that cable I had the other day go? Oh, there it is. The other day last week we were talking about the Ethernet cables, the Cat5 cables, and depending on the size of the transmission, we might only use the green and orange wires to run things in serial, or we might use all 4 wires to run things in parallel. So the format that our data is being transmitted in, is it, how's it set up? The network layer is the path taken. The actual path taken. So this is when we did the trace route in last week's lab. That's some of the information we were getting there. What machines are we actually passing through on the way from the source to the destination? And that way we don't repeat things. Right? Like if you remember when we were talking about IP, we drew that little spider web looking picture, had a whole bunch of different sites on it. And we don't want to get stuck somewhere in transition just because that's the best route, right? Like if site A is trying to communicate to site B, I think it's what we did that day, however the labels were. And maybe site F is the first one to communicate. It's going to send the data there first. And then when site F sends it out, we don't want it to go back to site A because maybe that's still the best connection. So site A looks like the best route through the network. So F sends it back to A. And then that cycle just keeps repeating and gets stuck. So we need to keep track of the machines we've already been to. That way we don't repeat things and get stuck in a loop. The transport layer, that has protocol data. So that would say this is being transmitted in TCP protocol. It's everything's 1024 bits. They're 800 bits or 800 packets. Each packet's 1024 bits. And the information about that particular packet, how is it being transported? So I'll put size and number, just because I ran out of room. But the packet size and number. Size and number. So how big is each packet and how many packets are there? And where does this one fall in the sequence? That way we know when we get all of them, or we know if some are missing. Or if data was lost. If things are the wrong size, we can check that en route and request it be sent again Like, okay, this is supposed to be 1,024 bits, but there's only 800 bits here. So something we can check along the way to see if something went wrong. The session layer. I'm gonna erase this. I'm writing the names of all the layers. We don't need to actually have the word 7 layers explicitly stated up there. You'll be able to count them. The two machines, the two connected machines. I'll put over here start and end. I ran out of room, but this is something that probably should have been on this side, but where did this data start at and where is it ending? Who's sending it? Who's receiving it? Those end goals, because it's going to bounce through a lot of machines along the way. So we need to keep track of that initial start and end spot, along with all the machines that it passes through en route. There's a layer called presentation, which has the sequence it goes in. The checksum. Encryption, which I ran out of room. So I'll just write encrypt instead of encryption. But the information about how it should go. So down here we have the number of packets. Right? There's each packet's 1,024 bits, and there are 50 of them. And up here we have the sequence that this particular one goes in. Like maybe this is the 8th packet of those 50 total ones when it goes back in order, so that the other machine on the other side knows where to put it back together. And then we have an application layer, which is the software to use. Browsers will open most software, so we'll just send it to another browser to use, but maybe it's a spreadsheet. So the computer needs to know that it's to open it with whatever the default spreadsheet software is. Or if we send a text file, open it with whatever the default text file software is. So it's not going to be specifically open this with Microsoft Excel. It would be open this with spreadsheet software. And those layers are mostly extra information, right? Here's our actual data way down here at the bottom. Then on top of that, we pile in stuff about what format is it in? What all machines have we passed through en route? So every single machine we pass through is going to add more to it. So it doesn't just, it's not static moving through the network. At the very least, it's going to get bigger on the network layer as it passes through more and more machines, and then that route it takes, the route it has taken gets bigger and bigger. What protocol are we using to transmit it? And other protocols, because there's going to be lots of protocols involved, more than just the two. We've talked about the introduction level here. But what protocols are being used? Is this data used with and on this data? Really, to start off with, think of that as the size and number of packets. What are the actual two machines involved, right? There's this huge interconnected network, lots and lots of machines that we need to access. But what are the two main ones? Where is it starting and where is it ending? The source and destination would be our technical terms for that. The presentation has other information, the sequence. Checksum is just a little bit of error handling en route. Because we have binary code, a bunch of ones and zeros. So if we add all of those ones together, we can check the parity really, really quick. We either have an even number of ones or an odd number of ones. So depending on the protocol being used, we'll know whether there should be an even number or odd number of ones. So if we're expecting an odd number of ones to come in, if we get an even number of ones when we add them all up, we know something went wrong in route, and we can request that data to be sent again. Any encryptions, because we need that up at a top layer, because yeah, when we break, in order to break the data back down, the other machine has to know what encryption was used to secure the data before transmitting it. Then the application is just what to open it with. So that's that overhead I was mentioning when we were talking about this. There's a lot of extra stuff that has to go in to getting the packet across the network securely, and where we can put it back together and like this on the other side. And at first that was a big problem when people first thought of that, because that's a lot of extra information that has to be included in every single packet that we send across the network, not just with every single file. Right? When we break that file down, we have pieces of the file, and every single piece has to have all that extra information. So from the actual invention of that to the time it really took off was somewhere around 15 to 20 years. But once most of our machines could handle all that extra little bits of data we need there, we haven't really gone back to any of the other protocols that use less overhead, because the machines never seem to complain about extra work. And as you look at it, you can see there's a lot of features in there to make sure that the data makes it across the network correctly, or at least close enough to correctly, and some redundancies and extra things to keep it in place. But the main thing is, for this, like always, for all the stuff in this class, those terms, the physical layer, the data link layer, the network layer, the transport layer, the session layer, presentation layer, and the application layer are all terms that you're going to see in weekly quizzes through several different classes. So I thought it might be good to go ahead and preview those here, get a first sort of look at them. That way they're not all foreign terms when you get to the classes where they're going to show up. Okay, so check that off there. How long was that? 43 minutes. Okay, I was looking for about 45 minutes. That was pretty close to the time, because the next thing on the list is the cybersecurity stuff, and that is a whole bunch of definitions today, things to talk about. So many pages, I'm probably going to break that up into 2 lectures and try to leave lots of time to catch up on homework and get all that stuff done. So it might be a good time for a break, and then we'll go for another 45 minutes, and then we should have lots of time to work on stuff in this block on your schedule that should already be marked off to learn IT stuff. Does that sound good to everybody? 10 minutes?
Yes, it does.
Yeah.
All right, so we'll get back to it at 1:54 and then go for about another 45 minutes because that's a lot of definitions in the cybersecurity section. I want to break that up over 2 days, spread that out over 2 days. So I'll see y'all in just a minute. I'm gonna go get some coffee, and I'll stop the recording, and we'll get back to it at 1:54.